So first you have your two equations, right? P plus Q equals 1. So
Okay.
this is for alleles, right?
Right.
That's not for genotypes. So what you have here is a genotype frequency, right? Because it has both alleles.
Oh,
You don't have an allele frequency, right? So what your question is, what is the rate of these heterozygotes and these, right?
right.
These guys, right? So for alleles you have this, and then for genotypes is you have p
That really long one.
plus 2pq plus q squared equals 1, right? And 1 is just another way to think of 1 is 100% of the population. So for alleles, right, the frequency of each allele is always going to equal to 100%. So
Okay.
it's like some portion of p allele plus the other allele q is going to be 100%, right?
Okay.
So it always equals 1. So this is a genotype, EE. It's not an allele frequency, right?
Okay.
So the common mistake is to like take say, oh, this is P, so then Q must be like 1 minus 0.04,
Gotcha.
which would give you 0.96, which would be incorrect. Another way of writing this would be like this.
Ah, okay.
Right? This would be the same thing, right?
Okay.
So because it's genotype frequencies, and the genotypes are those little combinations. So all this equation is saying is that your heterozygotes for 1 plus your homozygotes for 1 plus your heterozygotes plus the other homozygotes is going to equal 100% in that population, right?
Okay.
So if this is the case, this EE value here,
Mm-hmm.
what is that equal to in the genotype equation?
In the genotype equation, that EE value is 0.04.
Right, right. Okay. So EE, it equals 0.04 equals what in the equation? What did
Um,
we assign that to?
so that was P squared,
Right, p squared. Right.
right?
So if we want to find p, right now we have p squared equals 0.04, right?
So you would divide by 2 to get just P.
Not divide by 2. We take the square root,
Oh, okay.
right? Because p, the square root of p squared would equal p. And what we want is p, because once you have just p, then you can use that allele frequency equation.
So then,
So what's the square root?
so it's 0.2.
Right.
So
So if you square root that, you get p equals 0.2. Right? But is that a genotype or is that an allele frequency?
now that's an allele frequency.
Okay, so now what's q?
Q is 1, right?
No. Look at the equation for
Oh,
allele
the equation.
frequencies.
Oh, Q squared is EE. So
Well,
Q
no,
must be.
because okay, so now
And
you've
I'm just looking at the wrong thing.
well now you've taken the genotype, right, EE, and you've changed that into an allele frequency, right?
Okay.
So now you don't have to use the genotype type equation. Now you can use that value, p equals 0.2, and you can just plug that straight into the allele frequency because you just went from genotype frequency. Now you know the allele value for E, right? 0.2. So if you plug that into the allele equation, what do you get?
So now I have 0.2 plus Q equals 1. I'm solving for Q now, right?
Exactly.
Okay. So did you just treat like standard algebra equation and just cancel out stuff, or?
Yeah, just
Okay.
and then let me know what you get for Q.
So I got 0.8.
Right. So what is Q plus? What are your values for P plus Q equal?
1.
Should equal 1, right? So it checks out.
Oh,
That's just your allele frequency, though, right?
right.
So now you have those, which is great. But the tricky thing is when you go back and forth between allele frequency to genotype frequency. It's like you have to like kind of make sure you're not confusing the two, right?
Right.
So now you, based on what I just showed you here, right?
Right.
And here, now you can solve for the different genotype frequencies. So for example, what would be the equation for finding heterozygotes?
The heterozygous is at the E, big E,
So
little e? Or?
so this is right here, this is the heterozygotes, right?
Okay.
So what part of the genotype equation corresponds to the heterozygotes?
That would be 2PQ. So you take, so I just would take 2 and times it by 0.2 and 0.8, right?
Exactly.
So would it be 2 parenthesis PQ when I'm like putting into a calculator, or is there like any order of operations that matter?
It doesn't really matter.
Okay.
2 times 0.2 times 0.8. What do you
So
get?
I get 0.32.
Okay, so let's add 0.32. And then now do the same thing for
EE,
EE.
which is Q squared, so just 0.8 squared, which is 0.64.
Okay. So now that you have these values here for your genotype frequencies, right?
Okay.
What do those all add up to? And that's how you can kind of check to make sure you're
So then I would add up. So I'd go 0.04 plus 0.32 plus 0.64 gives me 1. So it checks out.
probably correct. So if this was 100 individuals,
Right.
one would be 100% would be 100. So how many of these are homozygous dominant?
That's big E, right?
Right. So one would be 100%. So
Right.
0.64 would be what percent?
64%.
64%. So out of 100 individuals, how many are homozygous dominant?
64.
Exactly. Exactly.
Okay.
And then how many carry the recessive allele but don't look like the homozygous recessive?
32 carry it, but
Right.
still have 2 eyes, and only 4 have the 3 eyes and carry it.
Exactly.